Hello guys, welcome back to another video. Today we'll be looking at organic chemistry. Alkanes. The alkanes form a homologous series. Like all homologous series, the alkanes have the same general formula, differ by CH2 in the molecular formula from neighboring compounds, show a gradual variation in physical properties such as boiling points, and have similar chemical properties. General formula. The general formula for the alkanes is CnH2n plus 2, where n is the number of carbon atoms in the molecule. So now we'll be looking at crude oil and fractional distillations. First, we have to know what hydrocarbons are. Hydrocarbons are compounds that contain hydrogen and carbon atoms only. So alkanes, what we looked at before, are saturated hydrocarbons, meaning that the carbons have only a single bond. Crude oil. Crude oil is a finite resource that is found in the Earth's crust. It is the remains of organisms that lived and died millions of years ago, mainly plankton, which is buried in mud. And it is a fossil fuel. So now we'll be looking at the formation of crude oil. So 300 to 400 million years ago, plankton and small creatures such as bacteria, protists, and algae who couldn't swim against the current died and fell onto the floor. So then the dead plankton were covered in mud. So that happened soon after, and then soon after, over millions of years, more and more sediment built up. The enormous heat and pressure turned the dead plankton into oil and gas. So there were different layers of rock, and there was trapped gas. Today, with the use of oil rigs, we drill down through rock to reach the oil and bring it up to the surface. So on the right is a fractionating column, and it uses fractional distillation. So it is used to get different things out of the crude oil, such as petrol, naphtha, petrol, which is used for cars. But at the top, there are refinery gases, which are a very low temperature. Then there's petrol, then there's naphtha, which is used for chemicals, kerosene, which is used for jet fuel and paraffin, diesel, which is used for diesel vehicles and trucks, and lubricating oil, which is used for machinery, fuel, which is used for heating and ships, and finally there's residue, which is used as bitumen for roads and roofing. So at the top it's cold and the bottom is really hot. So at the top, if it's cold, that means there are small molecules which have a very low boiling point. They're very volatile. They flow easily and ignite easily. And on the other hand, at the bottom, there are large molecules which have high boiling point. They're not very volatile. They don't flow easily and don't ignite easily. So now we'll be looking at the important alkenes. So the four important alkenes for GCSE are methane, which is CH4, ethane, which is C2H6, propane, which is C3H8, and butane, which is C4H10. So on the right there is a molecular version of this, and there's a ball and stick version of this. So because these are all alkanes, the carbons only have a single bond with other carbons and hydrogens. Fractions of crude oil. Each crude oil fraction contains a mixture of hydrocarbons. The hydrocarbons in a fraction are mostly hydrocarbons called alkanes. We have talked about this in the past few slides. They have similar number of hydrogen and carbon atoms in the molecules. They have similar boiling points, ease of ignition, and viscosity. So now we'll be looking at small alkalines versus large alkalines. So here's a table. So small alkalines have a low boiling point, runny, easy to ignite, and burn with a clean flame. So as we move to larger alkalines, the boiling point increases, the viscosity increases, the flammability decreases, and the cleanliness of the flame decreases. So large alkanes have a high boiling point, they're vicious, they're hard to ignite and burn with a smoky flame. So the last bit, which is talking about burn with a clean flame and burn with a smoky flame, it can be shown with a Bunsen burner. So when there's a blue flame, that means as a clean flame. As a smoky flame is when there's a yellow-red flame. So finally, we'll be looking at combustion, complete combustion. Complete combustion is where an alkane plus oxygen goes to carbon dioxide plus water. Complete combustion of a hydrocarbon fuel happens when there's a good supply of air. Carbon hydrogen atoms in the fuel react with oxygen in an exothermic reaction, in which carbon dioxide and water are produced and the maximum amount of energy is given out. So if you want to know more about exothermic reactions, please look at my previous video. Incomplete combustion. So the two incomplete combustion reactions can be alkane plus oxygen goes to carbon or soot, or another word for it, soot plus water, or alkane plus oxygen goes to carbon monoxide plus water. Incomplete combustion happens when the supply of air or oxygen is poor. So when the air is closed for a Bunsen burner, there's a poor supply of air or oxygen. So that's why it's a red/yellow flame. Water is still produced, but carbon monoxide and carbon are produced. Less energy is released than during complete combustion. Thank you for watching. I hope you enjoyed my video. Please like my video and subscribe to my channel. And if you want to know about more about exothermic reactions, look at my previous videos.